Hi, good morning. It's Miss Wang again. I'm going to have another example of graphing based on the transformation. Given the new parabola relation is y equals negative a half of x plus 2 squared minus 3. Okay, this is your new graph. Now, I'm going to graph this transformation, use the idea of transform of y equals x squared to a new location. So any point on y equals x squared can be expressed as ordered pair x and y. This point is going to be transformed according to your AKPQ value. A equals negative a half. Your h equals, what is the h value? It's x plus 2. Your formula is y equals negative 1 over 2 x minus h squared plus k. Now you look at here, k is easy, k is negative 3, but here is x minus h. X minus what give you positive 2? Of course, your h will be negative 2 because x minus negative 2 gives you x plus 2 squared. That's why this is something you need to think about it to recognize the correct h value, because the formula of the parabola vertex form is x minus h squared. Now you have those three parameters. Those three parameters, we know A is vertical stretch. It affects y value. And this is a horizontal shift, right? It only affects x coordinate. This is vertical shift up or down, only affect y value. Therefore, your new coordinates is going to be, look at it here, you do x. Your x only affected by the horizontal shift left by 2 units is going to be becomes left x minus 2. That is your new coordinates. And your y value affected by 2 parameters, a and k. Your y first stretch it by a factor of negative a half, and then your k is shifted down by 3. That is your new points. So therefore, for any points on y equals x squared, this will be, all the points will be on the graph of negative a half times x plus 2 squared minus 3 graph. Okay, now, based on this mapping rule, let's see all the points. All the points on the x and y, we use our traditional 5 points. When x equals negative 2 is 4, negative 1 is 1, 0, 0, 1, 1, 2, and 4. Those are the basic 5 key points. We're going to transform to find the new mapped points for the new graph, and by connecting a new point, we'll have our new graph. Therefore, what is the point? Transform the point from negative 2 and 4. So you transform this one according to this mapping rule, x minus 2. It is x is negative 2. X minus 2, you will get negative 4, because negative 2 minus 2 is 4. Here, negative 4. And here, your original value is 4. You are going to transform to negative half times 4 is what? Is negative 2 minus 3 is negative 5. And this is your first transformed point. The second transformed point is negative 1 minus 2 is negative 3. And 1 is going to be transformed to negative a half minus 3, right? So that is negative 7 over 2. Okay? And here, it's 0 minus 2, it's going to get negative 2. Here, 0, you get negative 3. You substitute x, y value into this mapping rule. 1 minus negative 2 is negative 1. And here, 1. So that is going to get a negative 2. Negative 7 over 2 again. And here is 2. Minus 2 is 0, and 4 is going to be substituted here, transformed to negative 5. Okay, when you graph this, you want to graph this parabola. This parabola's points are those 5 key points. By connect them, you will have your new graph. So I'm going to draw my x and y coordinates. Okay, now I'm going to draw those points. -4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And -3, 1, 2, 3. Okay, -7/2, that is -3.5. And -2, 1, 2, -3. 1, 2, 3. That's a vertex. And then next is -1, -3.5. And then it's 0, -5. 1, 2, 3, 4, 5. Okay, and you can see that those points are symmetrical. This is your new graph, y equals -1/2 x plus 2 squared minus 3. Okay, so that is your new graph. Did you see this graph? Because of the a value is negative, it actually reflected down, right? Reflected down here. Okay, and I hope you get this one, the idea of this is a table of values, right? Based on the transformation, based on the transformation in the mapping row. Okay, in the mapping row. The mapping row is this one. This is your mapping row. Any points on the y equals x squared is going to be transformed to a new location by that calculation formula. Okay, thank you for your attention.